So, good morning, good afternoon, and good evening. It is, I suppose, late afternoon here in Kent, where I am, but I know we have participants from all over the world. So, hello, everybody. My name is Rosalind Craven. I'm a principal analyst on the research team at STL Partners, which is a boutique telecoms and tech focused research firm. And I am going to be moderating this next panel discussion which the topic of which is Wi-Fi 8 on the horizon. Will it be the connectivity fabric for the AI era? Now, in the previous two sessions, we've had a little bit of kind of light discussion of Wi-Fi 8, but this is our real opportunity to get into the meat of it. What is it? What is it about? And we're going to be using this question of what its role really will be in the AI era as a way into that. But to kick things off, I'm going to ask my excellent panelists to take it in turns to introduce themselves. I'm going to ask them to introduce themselves and their role and organisation, but also to answer the question, what does Wi-Fi 8 mean to you? And to kick this off, I'm going to ask Khushboo to go first.
Okay, hello everybody. Thank you for moderating the session, Rosalind. I'm Khushboo Kalyani. I'm from LitePoint. We are a subsidiary of Teradyne, and we develop, basically design, build right from scratch wireless test technology solutions. So we provide solutions for physical layer RF testing that can be used right from the chipset characterization level up to manufacturing. And so we support design verification, volume manufacturing, chipset characterization across Wi-Fi, UWB, cellular, and a lot more technologies. For what Wi-Fi 8 means to me, it's like a dependable friend which shows up always, all the time. That's how I would describe Wi-Fi 8, the predictive dependent friend, which will ensure connectivity throughout, not just speed. Okay, I think I lost your Rosalind, you're on mute.
That is because I switched on to mute. Marcus, I'm picking on you to go next.
Yes, hello everybody. My name is Marcus Brunner. I'm the vice chair of the ETSI IFG F5G. ETSI is the European Telecom Standards Institute, and the group I'm vice chairing of is the Fixed 5G group. Fixed 5G group is looking basically in all types of end-to-end technologies for the broadband telecom system. That's the fiber to the home, the core networks, optical core networks. And the latest addition we have done in F5G is what we call the fiber to the room. It's basically a Wi-Fi access point in every room with backhauling it with fiber. That system view is basically looking at using Wi-Fi at the front end. And already today, for Wi-Fi 7 is currently the standards we use. In Wi-Fi 7, we already do a lot of coordination of access points. We already add AI for optimizing the Wi-Fi, things like that. And with Wi-Fi 8, we naturally hope to improve that, go even higher rates, because we can have several Wi-Fi access points across the whole system, in a home, in an enterprise, in a small or medium enterprise. So we hope to improve the overall performance of the system and have a much better quality, because we have not Wi-Fi and not mesh, but we have very proper backhauling of the Wi-Fi access points. And I guess we're going to further discuss that during this time.
Thank you very much. I'm now going to pick on Janne to introduce himself, his organization, and what Wi-Fi 8 means to him.
Hello, everybody. My name is Janne Linkola. I work for Spirent. We're now part of Keysight. And like Khushboo, Khushboo's company, we also manufacture testing equipment. Our product line is more oriented on performance testing, and so is used by ISPs and device manufacturers and access point manufacturers around the world. I think Wi-Fi 8 for me is an important stepping stone to enable the connectivity of the future. Wi-Fi has gone through a huge amount of growth. An average home in the United States already has about 20 different devices using Wi-Fi. Congestion and interference is starting to be an issue. We've in the history of Wi-Fi, all releases have had mostly a speed increase type of focus. Wi-Fi 8 is now addressing this emerging congestion problem in homes and elsewhere, and so reliability is very much required as we move into AI era.
Thank you. And finally, Andy, can you do the same?
Hi, I'm Andy Davidson. I'm from Qualcomm. We're a supplier of semiconductor chips for phones and for many different markets. In fact, we're probably the last Wi-Fi supplier who supplies Wi-Fi into every market. So we have broad interests in the applicability to the home, to the enterprise, and in general to industry. For me, the Wi-Fi 8, the most important thing is it's about performance. It's about the reliability of the performance that it is going to deliver. So speaking to the points that the other panelists have made, prior Wi-Fis have been very focused on increasing the peak throughput, but people say, well, I'm not always right next to my access point and I'm not always in a clean environment. Wi-Fi 8 addresses all of those other cases. It improves performance, improves throughput, improves latency as you move further away from the access point. It improves it as you move between access points. It improves it in the presence of congestion, either within your own network or from an overlapping network. So it's really all about being able to rely on getting a smooth, consistent throughput and latency as you move. And I think we'll probably talk further about the importance of hitting those sort of metrics and how that importance is increasing as we move into areas such as AI, where latency is absolutely key. And especially the AI experiences that we're now moving to, where there's far more data getting moved. It's not just about chat. It's going to be about delivering video and having analysis of video. So Wi-Fi 8 is going to deliver on getting the throughput you need, the latency you need in all the places that you need.
So, thank you to all my panel for introducing themselves, and I hope that for everybody this has given us a good starting point on what Wi-Fi 8 is about and what the panel thinks is interesting and important about it. We're going to dig into that a bit more now, and I'm going to put the question forward. What I guess, as Wi-Fi 8 is, moves through its standardization process and towards commercialization, and then, becomes a reality on the market. What use cases, what new and different use cases can we expect to be unlocked by this new technology? As Andy, you're still on my screen, I'm going to let you go first this time, or force you to go first this time, depending on how you feel about it.
I'm happy to go first. Well, I mentioned the AI use case. I think AI, we all see it increasingly taking a role in our lives. And I think one of the sort of exciting cases that we see is the ability to wear glasses. And the AI glasses are something that can see what you can see. You can talk to it at any time. And at Qualcomm, we talk about AI as the new UI, because really the way we will interact a lot with computing devices in the future is going to be via AI. Sometimes it's going to be via speech. Sometimes it's going to be, as I mentioned earlier, it's going to be video. What am I looking at? What is this? Tell me more about this. Those sort of cases. Either way, the latency is absolutely key, and a consistent latency. The thing that turns a sort of command response into more natural conversation is latency. And for the human experience, you have to just consistently hit that same latency of response in order to get that natural sort of flavor to the conversation that's probably required for people to start using it in that way. Wi-Fi 8 is going to help greatly with that. You know, the consistency of throughput, but also the latency, the fact that it can deliver the information you need in the time frame you need. It can get the information back to you, get the response back to you. That's going to be a critical use case. I think there's many others that take advantage of that latency where you open up the new areas for Wi-Fi to get involved with in terms of industrial control, etc. But I think it's important when you roll out a new technology not to lose the base. What's the first thing that's going to happen? I think this happened a lot with 5G. People talked in advance about many different new use cases, but the first way people experience it is the same way they experience it today. So that throughput, the fact that home, as you're walking about in your home, in more places, you'll get higher throughput. If you're the sort of person that walks around your home doing a speed test to make sure you've got that gigabit per second everywhere, you're going to see a much better experience with Wi-Fi 8.
Does anybody else, you know, have other use cases or other kind of new experiences that they expect to be unlocked by Wi-Fi 8?
I can add to it. So, first thing is, I guess we don't need to go that far. We can just look in our homes, right? Like, especially for gaming devices, they don't really, gaming has been a big market segment, right? And so these devices don't really need throughput as much as they rely on lower latency and lower jitter. So that's one segment that I feel will continue to benefit from every generation of Wi-Fi, and especially Wi-Fi 8. More AI workloads which require context-aware and predictive modeling. So more real-time AI workloads, whether it's in the industrial or autonomous factories where you want the robots to communicate fluidly, and also multiple robots to communicate fluidly, like addressing the user density with multi-AP coordination. That's a segment in industrial automation that's going to, I guess, benefit a lot from Wi-Fi 8.
I would just say this is certainly something that I often hear as a hit against Wi-Fi for in certain industrial automation use cases is when things need to move around a challenging environment and you need lots of handover, that those use cases tend to be clunkier on Wi-Fi. That's what people use to try and sell private 5G. So do people think, is Wi-Fi 8 going to solve that?
Sorry.
Let me tell.
Go ahead.
Go ahead. Yeah, well, just referring back to that use case on industrial. I mean, we are doing that already today with Wi-Fi 7. It's about the overall system. You need to tweak it. It's not only a Wi-Fi thing, it's the overall network system in an industrial setting you need to take care of. I mean, this is deploying depending on the region and so on. So that's not, in that sense, it's not a new use case. I think where it's really get new is the extreme low latency aspects. We have experiments done and proof of concepts done with some of our research partners in the ETSI group, where they really look into extreme low sub-millisecond area. What can be done? That's really like if you have safety in robotics. Robot need to stop early enough and quick enough if somebody comes near to the robot. So this type of things in the industrial side, I think that's very important. Now let me switch to the more home side, because from the broadband perspective, the home is naturally the more interesting bit, and there's much more scale in the home. And since we do this fiber to the home, which increases its bandwidth and its reliability, we need to check also the home environment and the home networking. That's why I said fiber to the room is the F5G approach to improve the home. Now we have the network now. Now what we do, there is a lot of different sensoring capabilities, either in Wi-Fi or with sensors. We have, for example, 3D sensor cloud, where it just looks like basically looking what type of points are there, what is moving, stuff like that. You can detect whether somebody's there or not with Wi-Fi. You can check things in the Wi-Fi boxes right away. you can do transcoding on the Wi-Fi boxes. We have a use case in ETSI, which is transcoding 2D into 3D glasses right on the box, and then sort of transport it over Wi-Fi to the glasses, things like that. So these are the type of use cases we have listed. If people are interested in a lot of like home use cases or broadband use cases, please check out. There are quite a high number of use cases we have written up in the ETSI document. All of that can be found on etsi.org, and you will be able to find things.
Janne, have we missed anything? Have we missed any kind of transformative, impacts that Wi-Fi 8's going to enable?
I think the team has summarized everything well. Just two additional things come to mind. And it really sort of builds on to what Markus there was just saying. So as we have more and more access points in a home, or let's say in an industrial environment, then mobility in between those becomes important. And Wi-Fi very early on adopted this device, oriented mobility model, and it has some limitations into how well Wi-Fi performs. Wi-Fi 8 improves that, but there are some new techniques there. I presume this will though continue, because I think mobility will become more and more important. And then the other thing that nobody mentioned was the extra long range features in Wi-Fi 8. There is a certain size to what the Wi-Fi cell can be, if you want to call it that. There have been, let's say, attempts at improving that along the way. But I think Wi-Fi 8 has a very well-designed feature that I think actually will deliver extra range. And it'll be important, in homes, in cases like sensing things, maybe you have security cameras a little bit further away.
Good. I mean, that, adding extra range to those kind of sensing type services that can be offered as a kind of smart home service will definitely gradually sort of increase the capabilities and the applicability of those kinds of services. Now, I have down in my notes to then move on to talking about how Wi-Fi 8 is going to compare to other connectivity technologies. But I kind of feel like we've talked about that, and it's sort of, it's less useful. I think at the Wi-Fi forum, it's already been mentioned lots of times today that all connectivity, wireless connectivity in the home is all Wi-Fi. And when it comes to specialist industrial kind of scenarios, it's a different conversation, and it's very unto itself. I think we're going to have more value if we move on and talk kind of about timeline, and then also kind of involved in that is the question of the key challenges. So I'd like to hear from the panel, what they think is the likely timeline to get through to kind of finalize the standardization and proceed to commercial rollout for Wi-Fi 8, but also what are the key challenges that we're going to be overcoming to get there. Let's let Markus go first. Markus.
Yes, so I have to admit I'm not involved in the Wi-Fi standardization. I'm a standards guy, but I'm really coming from the optical networking side. So, but I will also answer it exactly this way. So in the optical communication, we just have finished standardization of what we call the F5G Advanced, the 5th generation broadband advanced version or generation. There we basically talk that fiber to the home goes up to somewhere in the 40 gig. People talk about 10 gig per home, but the technology goes up to 40 gig per home. So if you bring that type of capacity to homes, basically you need to do something in the homes for distributing that. So having the distribution in the home is a very, very important next step, depending on what people want to do with it, naturally. And the second thing, from a more telecom side is really this high reliability, which we really need, because if you look at and if you talk with operators, they basically tell you most of their calls in their call center is because Wi-Fi doesn't work because of one or the other way. So improving this reliability as quick as possible. And we started with sort of improving as much as we can with Wi-Fi 7, and there are extensions possible, and I heard the experts will probably talk about that just after me. So basically this improving this type of things for the overall system is a very good way forward, and sooner the better, I would say.
Janne, would you like to go next, talking about the expected timeline that you expect to see before we see Wi-Fi 8 being a commercial possibility, but also digging into what are the most important kind of hurdles and challenges
Right.
that we need to solve?
Sure. Well, my crystal ball is a little bit hazy, but if I look at the history of Wi-Fi, new Wi-Fi releases have emerged from the standards at a rate of about once in 5 years, 5 or 6 years. If I remember correctly, Wi-Fi 7 was ratified in January of 2024. While I don't know how to predict the future super well, that's certainly one point to start from. Now, we already see products being launched, and I'm getting the sense that maybe Wi-Fi 8 will become a little bit earlier than that, but it remains to be seen. I think just overall, there are basically two challenges, right? One is interoperability, which is kind of in the domain of Wi-Fi Alliance. They have all these tests that are meant to ensure that. Beyond that, there are very few performance standards. So that's when then the availability of test equipment and testing things very thoroughly becomes important. That's where Khushboo and I come in. I would say that just from a testing point of view, Wi-Fi 8 is a very interesting departure in the industry, in the sense that there is the primary focus is not on speed increase, but it's on this reliability increase. And so this will mean that great emphasis needs to be put into how to test these things. New testing methodologies are going to have to be invented. New analysis tools have to be developed to ensure that Wi-Fi 8 meets the consumer's performance expectations.
Khushboo, as do you have another sort of testing perspective on these same questions?
I totally agree with Janne that we need newer testing tools and the type of testing. Wi-Fi has been out there for many generations now. It's not like right off the box, if your device comes out like an access point or a phone, it's going to be broken and there's going to be no connectivity. Those days are not going to be there. It's about how you test the Wi-Fi performance under interference or coexistence scenarios. How predictive is your traffic, right? How smooth is your rate adaptation curve, in the sense that you are at a certain distance, communicating at a certain modulation coding scheme from a physical layer perspective. If the distance becomes closer or farther, how smooth is your rate adaptation algorithm, right? These are design specifications for devices. So those are metrics that we are, especially working with silicon companies and product companies, we're realizing that they want to focus on going forward. So newer test tools and analysis. So more real world device performance measurement.
And Andy, what do you think? We've heard a suggestion that Wi-Fi 8 could be a little departure from the traditional cadence of Wi-Fi standards. Somebody thinks it might go a little bit quicker. But also, we've had a bit of a mention of interference, potential challenges. What do you think is the likely timeline and the most important challenges to overcome in the ongoing development and building the success of Wi-Fi 8?
I think is somewhat more predictable, personally. Wi-Fi Alliance announced certification for Wi-Fi 6 at CES 2020. They announced certification for Wi-Fi 7 at CES 2024. I'm putting my money on an announcement at CES 2028. If I'm looking at the tracking towards that, I would say the announcements are already coming out from the semiconductor vendors of the availability of Wi-Fi 8 chips, exactly 4 years after they did it for Wi-Fi 7, 8 years after Wi-Fi 6. The way the market kind of works is the Wi-Fi Alliance isn't really the start of the market. Wi-Fi Alliance can only launch an interoperability certification program once there's enough equipment for them to form that test bed. So usually the Wi-Fi certification is a kind of indication that the technology is going mainstream and you're going to see a significant ramp. I think we'll see early adopter products start to appear next year, late this year, kind of 4 years after the Wi-Fi 7 ones. I actually think it's one of the nice things about Wi-Fi 8 is there aren't any significant regulatory kind of blockers here. We're using spectrum we've used before. There's nothing new in the kind of signal shape or what we're trying to do that's going to draw the attention of regulators and get them worried about anything we're doing. It should be a fairly smooth progression in terms of the just people having to execute, and we can see that as well. We can see the tools vendors, which are critical, of course. They're also starting to make announcements about readiness for Wi-Fi 8. So I'm hopeful we will arrive on time and deliver what we're all claiming here.
It's interesting that you bring up regulatory concerns and spectrum, or the lack thereof, the lack of the regulatory concerns, because there has been a question from the audience, and they've said, isn't Wi-Fi 8 going to be constrained, if only limited to lower 6 gigahertz? I mean, I would expand that by going, do we have a reason to expect Wi-Fi 8 to be limited to the lower 6 gigahertz?
No, it's going to work in the same bands as the previous Wi-Fi worked. I don't know if the questions may be asking if in regions where you only have the lower 6 gigahertz, unlike the US where you can have like more than a gigahertz of spectrum available, some of the areas is going to be less. But I think even in those areas, you're going to see tremendous advantage from Wi-Fi 8. And in fact, this ability to use the available spectrum better is going to be a boon.
To add also to that is if you have multi access points, you basically start reusing the spectrum. So the amount of spectrum gets less relevant. So I also don't see really an issue here. Yes, like I guess the question came from Europe where a lot of discussion about the upper 6 gigahertz bands are happening.
I have absolutely no visibility at the moment who asked the question, so I can't comment on that. I mean, do we expect spectrum and sort of managing interference to be a bigger, a smaller, or the same level of problem as we move forward towards Wi-Fi 8?
Well, I mean, Wi-Fi 8 has tools for this now, better tools, standardized tools than before. But yeah, I think it'll be a much of a market-specific question ultimately. I mean, for example, in China, 6 gigahertz is not open at all currently, and is a major market, of course, as we all know, for Wi-Fi equipment. But yeah, I think the industry's focus on high density deployments, whether in industrial or like in apartment buildings, is the right thing to do, and I think there'll be tools where we can deploy this technology more dense.
Yeah, I think
oh, go ahead. Sorry.
I think it's going to be actually an advantage of Wi-Fi 8, the fact that it can you can get the performance you need even in the presence of that interference. I think people will see that is one of the key advantages.
Mm-hmm. I also want to ask the panel about power consumption challenges or potential power consumption challenges. Are there new challenges, as we develop equipment towards, to enable Wi-Fi 8? Are there new power consumption challenges within that to address?
From a F5G and fiber to the room perspective, if you have more access points, you can run them in lower power, and the backhaul is also like optics is very, very low power. So in that sense, but that's more of like an architectural approach. I don't know the PHY and the radio aspects in Wi-Fi 8 when there's particular power oriented or power saving oriented measures and tools available.
Maybe just a general comment. So and I think the power consumption would be most relevant for like battery operated sensor type of devices. That category of products currently tends not to be Wi-Fi based, but I think Wi-Fi 8 does improve power consumption, but I don't know if it quite scales to that. Maybe somebody like Andy knows a little bit better. It's not something that I personally have focused a lot on.
Yeah, the power consumption is very important. I think even for carriers, the power consumption of the routers is a significant proportion of their carbon footprint, even of the entire organization. So it is very important to companies. I think what we've seen so far is a lot of the improvements that have been done have been in implementation. There's obviously an improvement in power in each new generation as the semiconductor companies focus on improving the power. And I think there's other techniques that are getting brought to bear within those router markets where you can address the power efficiency. Some of the simple ideas are you don't necessarily need every band operating all night long while no one's awake. So there's some techniques I think you can see some of the leading carriers are bringing in themselves, which are moderating the power consumption of Wi-Fi.
I have actually seen a demo of a smart router management system that looks at powering down either completely or partially, as you say, different bands, and potentially switching the router off completely at certain times. There's been another question from the audience. Does anybody have any initial enhanced long range results in POCs or trials and its efficiency on Wi-Fi 8?
I have to admit, I'm not terribly interested in long range. I'm much more interested in even shorter range, like going probably even higher frequencies into millimeter wave type of frequencies. So that's where I would be more interested in.
I mean, maybe somebody else has. I haven't seen results, but I think I was sort of hyping it a little bit earlier there. I mean, I do. As I mentioned, there's it seems to be quite well designed, this feature, and so I fully expect it to deliver a boost into the range. So very much looking forward to the first results.
Has anybody else seen any or heard of any results in experimenting with the ELR capabilities?
Well, we have nothing public yet in terms of
So maybe, but you're not going to tell
making.
us.
But let me just comment that from simulation, let's say, there's several dB of improvement that we're seeing, that we expect. And I think we will deliver on that.
In the absence of any further audience questions, in the last couple of minutes, I'm going to put my slightly contrary question to the panel, which is, I suppose, why are we doing this? There is a tendency, and we can certainly look at this in the sister industry of mobile technologies, that there is often a sense that, well, you have to do the next thing. And there's being a bit of pushback on that. And, we talk about the regularity of these certifications being announced every 4 years at CES. Is there any kind of tendency to just come up with a new standard, to come up with, a new number, just because that's what we do and that's what's expected? Or are we doing this because we really, really need it?
I actually think we really, really need it. And you see the change is with Wi-Fi 8 is not focusing only on this speed dimension.
Mm-hmm.
I think really that's really the change where the industry realizes that a lot of other aspects of networking are getting more important. You want to have this better quality of experience, this lower latency for certain applications, things like that play a much bigger role. Having much more automation into the systems, things like that start playing more and more a role, not only the speed dimension. So I think that's the Wi-Fi 8 setup, or the direction Wi-Fi 8 is taking, is exactly trying to address those aspects. Probably at the moment, the appetite for much more speed is not there, as you say. So it's not because only of the speed we do that, but I think we do it because of the other dimensions and directions of an overall system.
Yeah, I would agree that we fundamentally need this, because I think for past many generations, we've just added like more channels, more MIMO schemes, more spectrum, and we don't really need all of that. And the fact that Wi-Fi 8 is kind of trying to add features to optimize whatever you have is what we need, which is reliability. Also, for the devices operating at edge, there are features like ELRPPTU or distributed RU, which operate on like basically it's for low power indoor devices operating at 6 gigahertz band, kind of helping extend its range, and not kind of, because the edge devices suffer the most, right? So kind of helping extend their range, helping them reuse the existing power they have. Also, from a bigger use case perspective, now we'll see more of these AI workloads and kind of systems. They essentially operate on 3 pillars, right? Access to lots of data, which is capacity, which was addressed by Wi-Fi 7 with 320 megahertz. Access to faster speeds, which is again addressed by Wi-Fi 7 with 4096 QAM. But the third aspect is reliability. You need the lower jitter and lower latency. You need access to data no matter what, right? The odds of successful transmission and reception have to exist. So that's the key pillar of the AI applications going forward. And so Wi-Fi 8, I think, rightly addresses that key pillar of the applications today and going forward.
Yeah, I think Rosalind, consumers need this. Connectivity to the internet just makes sense, right? Almost any there are thousands of problems that can be solved with connectivity to the internet. And Wi-Fi is the fabric to the internet currently, and will continue to be, and it needs to be improved. It's practically impossible to buy any kind of consumer electronics nowadays that does not have Wi-Fi. I mean, I've got a coffee machine at home that has Wi-Fi. I'm looking forward to the toaster with Wi-Fi. And so consumers need it. It helps our lives. It connects us to our loved ones, and it makes our lives easier.
I think we may be, thank you very much, panel. I think we may be out of time. So, Andy, if you had any final comments, tough luck. But thank you very much to my panel, and thank you to the audience. I hope that you found this, an interesting panel. I certainly feel that I've learned a great deal about Wi-Fi 8 and where the industry is heading. So, thank you very much, everybody.
Thank you.
Thank you.
Thank you. See you. Bye-bye.